Good afternoon, everyone. Welcome to today's webinar, Turn Historical Data into Actionable Intelligence Using Analytics. My name is Drew Gidwani, Director of Analytics here at ThreatConnect. Before we get started, I'm going to take a few moments to go over some housekeeping items, and then I'll hand it off to our first speaker. First, everyone's microphones have been muted to keep background noise to a minimum. If you have any questions, please feel free to ask them by typing them into the questions feature of GoToWebinar, and we'll do our best to answer them all at the end of the webinar. Second, we will be recording this webinar and sending out the recording in an email to everyone as soon as we have it available. So without further ado, we're going to first hear from our guest speaker from Forrester Research, Josh Salonis. Josh is a senior analyst at Forrester, serving security and risk professionals. He covers security architecture and operations with a focus on cyber threat intelligence, detection, and response. In this role, he helps clients continuously adapt their architecture, policies, and processes to evolving threats, while also developing robust incident response capabilities that limit the impact of breaches. His research focuses on threat intelligence, vulnerability asset management, malware analysis, and incident response. And with that, I'll turn it over to Josh.
So, welcome everybody. As introduced, I'm Josh Salonis, Senior Analyst at Forrester, and I'm here to talk to you about using attack trends to inform security strategy. And to accomplish this, I want to start by dispelling a myth of unlimited time and unlimited resources with regards to why attackers are guaranteed to get in. The truth of the matter is that there's value to your assets, and there's economics that dictate what it's worth to go after those assets. So it's important to understand that attackers don't actually have unlimited budgets. And to that end, it's important to start thinking about cyber criminals as enterprise businessmen. They find a gap in the market and they exploit it repeatedly. To do this, they need to develop and maintain infrastructure. And according to the Forrester Global Security Survey, 42% of respondents experienced at least one breach in the last year. And of those, 56% of them did so at the hands of an external threat actor. Now, that's quite a few attacks. So let's start thinking about what the infrastructure is that an attacker would need in order to start going after you in that manner. They're going to have the cost of developing software. They're going to have the infrastructure in order to do so in terms of your DNS, IP addresses, whatnot. And so what you run into from an economic perspective is really that it doesn't make sense for attackers to go about burning their infrastructure after each engagement. And if anybody is experience working in a dev shop, you know that they certainly wouldn't have time to be attacking this many targets if they had to develop new tools after each engagement. So the question is, how are they hiding? Now, David Bianco developed the pyramid of pain. And this was initially just used to describe the difficulty or pain that you would cause an attacker by denying them of these types of indicators. But let's reframe this for a second and think of it in terms of how aggravating it is or how expensive it is to go and shift this infrastructure. Now we can look at things like hash values, and you can say, all right, well, this is trivial, and any number of endpoint vendors are going to have this capability built into their demos for you. You've seen this. You know, they add a couple null bytes at the end of a binary file, and all of a sudden you have a different hash. If we start looking at things like DNS names and IP addresses, and I would assert that FastFlex DNS is a great demonstration of why domain names are on top of IP addresses here. It's a lot easier to shift IPs than domains. Similarly, we start to get into methods of communication or artifacts, registry keys that are left behind by malware. And these are kind of, I would say that they're the attributes of the runtime of the software that has been developed for the attack. And finally you have the tools themselves that may in some cases need to be rewritten. But if we're looking at this, the hardest thing for an attacker to change is their tactics, techniques, and procedures, because this is their habits. This is what they themselves think that they're good at and what they're used to doing, how they're used to going about doing things. And that is the hardest thing to change. And to that point, I'll ask, how many of you took a different route to work today? So getting into indicators, they get a lot of flack. And it's interesting why this is. If we take a look at the Verizon DBIR report, 99% of malware hashes are seen for 58 seconds or less. Now, I'm not being literal when I say that it takes longer than that to upload and analyze a piece of software, but it's pretty close. And so if we're taking a look back at the pyramid of pain, you have to realize that you have a very lazy attacker if you ever get a hit on a hash. But to that point, it doesn't mean that file indicators are useless. And this is where we start talking about sticks. Sticks is a framework for understanding the relationship that actors have to their handiwork. And so having a file hash in and of itself may not be extremely valuable. In fact, there's plenty of arguments that it is not valuable at all. In fact, it creates work items and effort and costs you money to process to no tangible known benefit because you don't have the context behind it. But an indicator with context allows you to start to do a link analysis, which is extremely valuable. It allows you to begin to see the big picture, allowing attribution and more efficient hunting, as we will see in a few slides. But before we go on, I want you to start thinking about sticks in terms of the reactive intelligence that goes into it. This is the indicators and the historical attack trends and historical data that we have that allows us to populate this, which helps us understand as a composite the motivations and capabilities that allow us to then in turn be proactive about our defense. Now to that, it's not always about indicators. And in fact, understanding how attack trends are developing is essential to the enterprise, because you can't always just put an indicator in the SIM. There's strategic information beyond tactical indicators that you need to be aware of. And social engineering is a great example of a non-technical challenge that you largely can't just put a signature into your SIM to solve. This is actually an attack on people. People are generally motivated by two things. The stock market, they'd say it's fear and greed, but I would say that it's actually fear and the need to feel liked or loved. And so what you end up having is you have people that will do things for you because they want you to like them. And it manifests itself in the craziest of ways. But it's no secret. You have 74% of targeted attacks using email as a vector. Your people know to go after the human. And in fact, according to the FBI, there's a $1 billion industry behind business email compromise, where attackers are usually impersonating somebody like a CEO and then asking for money or assets to be transferred, and people do it. So understanding this type of social engineering threat and the trend behind it, the FBI statistic was 2.5 years starting in October of 2013 through May of 16, I want to say, that it was $3.1 billion in assets lost. if you're taking a look at something like this, you need to ask yourself, how can I stop this? Because it's coming in as an email from an email account that quite possibly is legitimate, and somebody's just asking, somebody in authority is asking somebody else to go and transfer money. And so this is where you need to start looking at how you can build possibly additional process checks into your business processes, or even leveraging something like UBA technology as a fraud prevention technique. But the other thing that we're seeing a lot of it is other people's problems. There's a monetization of breach data that's happening and having a wide area of impact. Now, according to Internet Live Stats, there's roughly 3.5 billion Internet users worldwide. To start to put a perspective on the breach situation, or the amount of breach data that we're experiencing, when Yahoo lost 1 billion records, that's roughly 28% of the Internet. So what happens after that? Hackers they're trying these credentials absolutely everywhere. An example of this is Dropbox. They were compromised and lost about 2% of the Internet because an employee reused their LinkedIn password for their corporate systems. And LinkedIn lost about 4.5%. So you can see this chain here that LinkedIn was breached. They took the value of the credentials from that and got in somewhere else. And where else is this credential stuffing is what this is referred to. Well, where else is this happening? And one of the amazing things about this is that Points Guy, for instance, says that points are worth 1 or 2 cents each. And we're all business people. We likely all have Marriott rewards or some other rewards program that we're belonging to, cashing in when we're forced to go on business travel. Do you really care about your rewards credits? Right? Is that something that you prioritize as high as, say, your bank or your personal email address passwords, or is it something that you're using a generic password for? Many, many people just treat these accounts with disdain and weak passwords. And the impact on that is not only that they lose their points, but that the companies who have these points programs that are designed for engaging customers and rewarding loyalty are in fact turning customers away because they're seeing that all the work and all the loyalty that they built up is being stolen away from them by some third party. And this is happening to an extent that surveys are showing 72% of loyalty programs are struggling with fraud right now. So this is not a small problem. Another place where other people's breaches are causing headaches is supply chain. And this is a dirty, dirty subject. If you look over the past 2 weeks, Apple just dumped Supermicro over malware-infected firmware. They found that they had servers infected with firmware malware in the firmware that was running things like Siri and their App Store. So they're now, this has hurt Supermicro because they're losing the business, and it's of course hurting Apple because now they're having to deal with it, plus any kind of reputational fallout that may occur from such an incident. Also, Brian Krebs just released an article on the Kingslayer campaign. It was found that through a compromised download page and an update server, that 5 major defense contractors, 4 major telecoms, over 10 Western military organizations, 24 Fortune 500 companies, 24 banks, and more were compromised because a vendor who had a log management software tool that was widely used by administrators, privileged users, if you will, had been compromised. And the worst part about this is that there was essentially no notification. So that you had to find out on your own. So looking at this, there's really three areas where you can start to look at attack trends and you turn that to your security benefit. And we have how Intel analysts are able to collect and attribute data, to really show that, hey, this is legitimate information that's getting generated. And then we're going to take a look at how attack trends are being used to inform vulnerability management as a use case. And finally, we're going to talk about intelligent hunting and incident response. Now, people talk about the deep and dark web as though there's a spooky old tree out there. This just isn't the case. The dark web in particular just indicates that there's a protocol layer similar to SSL. It's using Tor. That's it. You have sites out there. Everything's like everything else. Just a lot of the 3.5 billion users of the internet aren't aware and don't use it. But open source intelligence has a lot of value, and this is due to a pervasive lack of operational security. And there's really three reasons why this is the case. One, you have people who aren't necessarily sophisticated a lot of the time, and you'll see examples of this. And maybe as the infrastructure is getting set up, you're going to engage a consultant to come in and help you build a phishing site, and somehow they will leak credentials that is going to cause eventual attribution back to you. Sometimes the attackers just don't care. Maybe they're in some country that has no or has non-extradition, or they have government support. And finally, there's a market-driven need to provide availability over confidentiality. And so if you look at it, OPSEC costs you money. At the very least time, which can be quantified, but it's difficult and it costs you money. It makes it difficult for consumers to find you. And so, criminals are needing storefronts so that they can advertise and sell their wares. They can't do that if the consumers can't find them. Ransomware victims certainly need help paying ransom. In fact, there's call centers out there for people to call in and get support with their ransomware issue. And of course, then we have activists who, if they go and DDoS somebody off the web and don't take credit for it, what was the point? So there's a trend to understand when developing a collection strategy for your threat intel capabilities. And this is something to keep in mind, is that there is value in open sources. Next, I wanted to touch on the attack trends that are influencing vulnerability management. And a critical example for understanding how you can use attack trends to inform security strategy is the use of exploit kits in criminal enterprise. People, particularly network penetration testers, used to push the concept that exploits were used to compromise perimeter devices based on exposed services, that you would then go and move laterally through the system in order to get to whatever data that you were after. But really, this isn't what we're seeing so much, is that it's this use of exploit kits. And what you have is you have people spamming from stolen email accounts. So this is getting into the credential stuffing. There's been a breach somewhere, somebody's credentials have been leaked. Somebody else, an attacker, logs into their email account and starts sending out spam from a fully legitimate account. You're going to have a heck of a time trying to stop that from getting in. You also have the strategic web compromise, is discussed before with the compromise of the log kits. or the logging software, you're able to turn these websites into water coolers. And then finally you have malvertising, and if anybody's familiar with or enjoys the show Mad Men, you can understand that advertisers only care about money, and so they don't really care who they're selling to. And these criminal organizations are buying impressions, and there's not much that you can do about it when you're watching numerous Fortune companies getting compromised. So what happens is you have all these different techniques, the spamming, the water cooler attacks, and malvertising that are essentially performing traffic shaping in order to drive impressions. And this is done using a traffic distribution software like Kitaro, which will then go and fingerprint the victim system to look for things like antivirus software, for instance, and make a determination if it's going to redirect to a legitimate source or to an exploit kit, such as the Sundown exploit kit. And you can actually rent these exploit kits for, I'm going to say about $500 a month is about the going rate for exploit kits right now. So really there's no reason for threat intelligence vendors not to be able to help us understand how or what vulnerabilities are being exploited by these exploit kits. And if you look at all the work on the left side of this graphic that goes into driving traffic to the exploit kit, all of that goes to waste if you've patched what the exploit kit's actually exploited. So, I'm not going to say that you can solve world hunger by going and keeping up on trends with exploit kits and then making sure that you're patching your flash vulnerabilities or whatever the exploit du jour is, but you're going to go a long way in that direction. So, here again, understanding the trend, understanding what the techniques of the attacker is going to help you even in your vulnerability management. Finally, I wanted to get back to the link analysis that we talked about whenever I was discussing sticks. What happens when you have these, let's say, low-value indicators that, again, the DBI are saying every 58 seconds these file hashes are changing and whatnot. Well, you don't want to go and subscribe to an Intel feed that's just going to dump hashes on you and put it into your SIM and hope that you're catching things. You're going to impact the SIM, you're going to impact your network. It's going to cost you money on your in your SOC for any kind of false positives that start coming up that people have to chase down. So using historical indicators on historical data will help you identify attacks. And so this is one place where you can start using threat hunting, because you know that in the past a particular actor, and again, here's where context comes into play. If you know that a particular actor has been going and pursuing or has compromised at some point in time, you know to start looking for other pieces of information that this attacker has presented or is associated with this attacker. And looking at this risk management workflow that we have here, part of incident response is an RFI process where you're going and actually pivoting off of the information from that is encapsulated in sticks. If you know that you got hit with a particular hash that is associated with an actor, what you can do is you can take all the indicators that are associated with that particular actor and use those to hunt the threat to ground and eliminate the threat. So with that, I'm going to pass the torch back to Drew, and thank you very much.
All right. Thank you very much, Josh, for setting the stage there. So when we look at everything that Josh just covered, I think it's really important to understand the breadth and the depth of the data that we have in hand. And if you look at all of the things, the trends that evolved in 2016, I think we need to start learning lessons on how to make better decisions in 2017 and how to shift from reactive to proactive. I could go on for hours talking about how to best leverage your data, all the data that you do have, and to kind of spare you guys all of my overexcited geekery there, I'm going to outline what I think are kind of the key takeaways in taking data and making it into an actionable decision. To start, in order to do that, I kind of have to show you what we call the information hierarchy. It's kind of like how a bill becomes a law, but it's more like how data becomes decisions. So if you start at the bottom of this graphic, right, and you look at data, I think we can all identify with data. We live in a world of raw data. For decades, we've been collecting kind of raw facts. It's just something like, I saw an IP address attempt to log into this server at this timestamp. The problem is that data on its own doesn't actually tell us anything. What we need to do is provide some context around it. And then it kind of gets promoted into information. So using the example of an IP address that's trying to log in, maybe some of the content behind it is that it's trying to use a protocol like SSH to log in, and it's doing so on a non-standard port. Or maybe it's coming from a country where I don't even do any business. And now I start to have some information that tells me that I may have an anomalous or maybe a malicious event. When we start to take patterns of information, then we can promote it into knowledge. I can now say that I know things based on my experience or different research that I've done. And maybe I can say that when I see some anomalous login attempt like this, it's a precursor to something more sophisticated or nefarious. And that knowledge is kind of, you'll see the color shift here, where we stop worrying as much about the past and start shifting into our focus on the future. So sufficient knowledge tells me that I can start making some informed predictions, right? I can look in this proactive stance, and that's what we call intelligence, right? I now have intelligence about what an adversary is likely to do next, and then that intelligence can start to inform decisions. It lets me prioritize, I know how they're going to attack, what that's going to look like, and where do I need to focus my resources to defend myself. If you look at the left side of this graphic, you'll just see a big old bar that goes up and called analytics. I think it's really important for us to kind of define analytics within the scope of this webinar. I think it's a fun word that gets thrown around a lot at this point, probably means different things to different people. It just sounds like a smart thing that we should all be doing all the time. I like to think of it as a well-defined analysis question and answer that serves kind of an information need. And you need to define that information need because maybe this is something that needs to run automatically. And when I ask that question every night over a huge data set, I need to do something different if the answer changes. Or maybe the data set is so large that it takes an hour to get an answer back, so I really have to put more thought into my questions. Or maybe you're just kind of doing some exploratory analysis and you don't quite know how to word the question yet, so you're still moving pieces around. The best example I can give is, looking back to my experience as an analyst, when I used to do hunting for new threats in our network, I would always train the new hunting analysts on this concept of we're looking for bugs under rocks, right? Picture being kids at the beach or something. The smart analysts, they were always good critical thinkers and they had good domain expertise. They knew which rocks to turn over first, which ones were more likely to yield the different bugs. They would start to look at these patterns, right? That becomes knowledge. And then they could sort of structure the way that they went about their job. They knew that they were going to turn over red rocks first because those gave the most bugs. So an analytic allows you to kind of capture and codify some of those inferences. And that's really how we can start to turn data into intelligence. That's the mechanism that lets us promote data up this model. They allow us to add context and meaning to capture knowledge. They help me decide what's noise and what's signal. And if you think back to that question and response model, analytics allow us to ask things like, well, how much login activity should I be seeing from that country? Or how often do we see these weird port and protocol combinations to know that something's a little weird? When I talk about using analytics to generate intelligence, it's absolutely critical that we store the data and, by extension, the information and the knowledge in a usable form that enables those kinds of questions and answers. And that brings me to what we're going to call the information model. And information model sounds really fancy. It's really just a specification of kind of data semantics. How does your data behave? What are the rules, the constraints, the relationships? If you needed to describe people as an object, you would describe Drew and you would know his gender, his age, his moderately attractive or at least interesting to look at. And the interesting thing about your data model is that it's going to determine what you store and how, and it's kind of got to be informed by a why. And before we really get into kind of the nuances of making an information model, I want to put out the caveat that you're never going to have a perfect information model, but some are definitely better than others, and with a little forward thinking, you can actually save yourself a lot of headache later. So what makes one better than another? This is just a couple examples of some of the trade-offs that you're going to have to make. So think about something like storage versus recall. For storage, databases, they exist for a reason. We don't store everything in flat files because they're difficult to do certain kinds of computation and look up on. If you understand the kinds of question that you want to ask, a quick Googling will show you some of the types of trade-offs you can make in various technologies, and that's going to kind of inform your decision on how you want to recall it. Scale versus fidelity, it would be amazing. Our jobs would be a lot easier if I could get full network capture of every packet that's ever flown across my enterprise network, but we don't really live in that world. So you kind of have to start making some compromises, right? Do I want to get full take PCAP capture for 1% of the traffic on my network, or would I rather get 100% coverage but like zoomed out a bit more and get what we call net flow data, which is metadata about IP addresses that are talking to each other with some surrounding contextual information. And the last thing that I really want to point out is that the key trend here is that things that appear to be boring facts today can become interesting intelligence over time. There's sort of emergent properties of the data that you don't really know in advance, but you can look at the classes of things that might eventually help you make correlations and might decide that something's interesting. Things like port numbers, protocols, all that sort of stuff. And we're going to get into some examples of this in a little bit. On the right, you can see some examples of part of the information model that we use here at Threat Connect. These are some of the different types of objects that we know we care to track, some of the different properties of each object that we think make them interesting and help with some analytics down the road. So I talked a little bit about recall patterns, and I want to dive into that a little bit more. I think classification of information is important, and you're probably already doing a lot of this in your job if you're already doing analysis. Even if you're not familiar with this space or you're just getting into it, there's probably all sorts of ways that you prioritize and organize information when somebody asks you a question, right? In defending our networks, we say things like, well, these are the crown jewels, right? This is where all the customer data is, or if this thing gets breached, then I'm going to have some real brand issues, or I'm going to have to call the lawyers and pay through the nose. And that helps us put things into different buckets that matter. There's also the question of kind of filtering, right? How do you remove the signal from the noise? How do you decide which rocks are interesting? And what are the properties that allow you to kind of make those sweeping statements so that as you start to clean up your data, you can get out the valuable stuff more quickly? I find that when we're developing analytics, it kind of helps to think of things as a question and answer sort of Mad Lib, right? This goes back to the Q&A model. And think about the blanks that you would need to fill in, right? What are the nouns or the verbs and adjectives that you would need to put in there? Show me all of the IP addresses where the login activity looks like this. Those are the kinds of things that you want to start thinking about capturing in your information model. Again, to the right, we actually have some kind of grouping objects that we use that allow us to convey different types of relationships, why things are important, or why they should be treated in the same bucket. Are they part of the same incident or part of the same malicious email that came out? So before we really get our hands dirty, I want to talk about two key points of actually implementing your information model. The first thing is centralization, which is bringing everything into the same place in the system of record. If you think about the human body, there's a reason why we don't have chunks of brain in our hands and feet. It's all in one place. It's all doing the same thing. And there's a lot of reasons for that, right? There's economies of scale. So people have already invested a lot of money in different technologies, different processes, different teams. And as those devices and feeds all need to talk to each other, if you start introducing latency time to move back and forth or computation time, you suddenly become less effective and you're creating more work for yourself, especially at the enterprise scale. There's a component of collaboration and visibility. If you've got multiple teams, maybe you have a threat intel team and a SOC and incident responders and forensic analysts, it becomes really difficult to do that. You may have silos established within your organization with different access controls and things like that. And having all those silos in the way really makes it harder for people to do their jobs. Having a system of record kind of follows from that. If you've got multiple cooks in the kitchen, then there's a lot of things that you need to do to make sure that you're able to audit yourself and see how things progress. Sometimes things get broken, things get refuted, things need some historical context, and things need to get rolled back. This can only really happen if everything lives in one centralized location. The second key component is normalization, and this is really talking about making all of your data act and look the same. Again, there's an economy of scale thing here. If you've got different devices, and this guy says that this is an IP address, and this other thing says that I need a CIDR block, then you have to do some kind of computation to say that one of these things is the other or part of the other. And so if you don't kind of have that common language, then you have to repeat all that work over and over again anytime you need to do it. And when we talk about analytics and working at a large scale, that starts to introduce a pretty substantial cost. That recall-driven design that we've been talking about, think about the way that you are going to ask questions, and that will kind of dictate the common language for you. And the last thing that I want to point out, it's not super fun or sexy, but data hygiene is actually really important, because bad data is going to make its way into your system, and it's going to happen at every step of the process, right? When you're collecting things, when you're trying to process or normalize them, when you want to ask those questions and do analysis, and then even when you're generating the outputs so that you can give a pretty chart for your boss, you're going to need ways to kind of clean up the data and say, don't worry about that spike in the chart. That's when I tripped over the Ethernet cable and things like that. So I'd like to get into kind of a real world example here. And for the sake of time, this isn't going to be like the latest and greatest, super sophisticated attack, but it's going to walk us through how we are going to take some raw data and turn that into actionable intelligence. So in this hypothetical, let's say that a report comes out. We know that there's a new type of attack or adversary that's targeting my industry, and it's heating up. And we're not going to focus on the attack vector right now, but what we do know is that once they're in the system, they use the remote desktop protocol, or RDP, to do some victim administration. If you're not familiar with RDP, it's what your sysadmin might use on your Windows machine to kind of take control of your mouse and keyboard and click around. So what we find is that these attackers sort of open up that RDP session and then just leave it running for them to use long term. And then to kind of obfuscate who they actually are, they route all that traffic through what we call a virtual private server, or a VPS. And that's basically a server that they rent from a VPS provider. So my boss comes knocking on the door and he says, hey, I need to know, have we already been had by this? Or, if not, can you set up some monitors to let us know if something kind of trips that wire for us? So now I have that information need, right? This warrants a new analytic. The do we have this already? And the monitor is kind of an extension of that, like let me know if this happens. So there's some kind of first order questions that we want to answer, and for the sake of time, I'll kind of skip past them, but you're going to want to ask a lot of questions like, well, what does normal RDP traffic look like for us? How can I tell if something is even a VPS server? And these are well-defined information needs, and they have well-defined solutions to kind of capture that knowledge. What's really interesting is the way that we can start to chain those together and promote that knowledge into intelligence and use that to drive some decision making. So for that, we're going to actually look at kind of a notional flowchart here. So this is a notional analytic that fires when a new IP address gets added to our centralized threat intelligence platform. If an information model and system of record have been designed appropriately, then we can actually start to capture some context alongside that new IP address that gets logged. And that's going to be critical for us to promote things up that hierarchy. So starting at the left and working our way over, we've got an IP address that's getting added. We're going to assume that there's some supplementary context, like the type of connection that we saw. In this case, we're obviously very interested in the remote desktop protocol or the RDP session. And there can even be some supplementary context that gets captured around that data, like the length of the RDP session. So let's say that I did some really quick analysis and I looked through my data and I found out that all of the remote desktop sessions that are normal users logging in, the sysadmins doing their stuff, those average really about 20 minutes. Anything beyond 20 minutes we think is kind of anomalous or abnormal. So I can start to look at that pattern and start to turn it into knowledge. Looking at the previous slide, we said that RDP traffic was routed through the VPS servers, so I may have some supplementary enrichment, some feeds, some extra devices in place that help me identify whether this IP address is part of a VPS provider net block. So if you look at the first kind of decision point in the flowchart after the RDP session, this may already be known to be a VPS, and if so, we're going to treat it differently. I may have some supplementary information, like I said, that I can bring in. Maybe I look it up in a feed or a VPS checker app or something like that, and if it matches those criteria, then I can add the tag for later analysis. And we move to, towards the right, there's this box here on changing the rating and confidence. So now I can start to store the results of some of these questions, the answers that come back, and that can kick off further analytics, that can inform further decisions, and I can create investigative tasks. So what I've done here is I've taken properly modeled data and I've turned it into intelligence, right? Those follow-on investigations, the mitigation activities can happen. They can happen in real time. This is, actually a process that exists as a playbook in our platform. And it's only possible because we were able to model our data and able to recall after the fact. So now that we normalize all that information, we can ask those questions, I can enable that high-level decision-making, I can find all of the VPS, RDP things, and anytime there's a future similar attack, we can respond appropriately as well. So there's a lot of fun analytics. Like I said, I could talk for hours about this stuff, but I do want to take a second to point out some of what I would consider to be like the second-order benefits that come along with developing a robust information model that might not be immediately obvious. The first thing is that it standardizes collaboration. When you're working on a common information model, then your teams can work seamlessly through that centralized, normalized system. It solves a lot of the problems that I used to have as an analyst, and we've seen, especially in our customers, there's a lot of gains that come out in that second order of things. One of them is it immediately fosters critical discussions that had never taken place before, right? You start bringing these stakeholders to the table, it highlights information needs, it highlights where there's gaps, where there's silos, and it helps people kind of tear down those walls so that they can do their job faster. It helps with external collaboration. What we've seen, we had customers that were all in the same industry, they were meeting up for burgers and beers, and they were just talking about the adversaries that they were seeing. And when we got them in a room together and got them to start talking about the information model, they were able to start capturing exactly why they cared about one adversary over another, and they developed a scoring mechanism as part of their information model so that as an industry, they could tell each other, hey, you should care about this guy more than this other guy because he's well-educated or well-equipped, or he's going after the crown jewels and that's his prime directive. There's also something to be said about internal collaboration and the way that that gets improved. I think there's always a need for better knowledge management within a company, right? You've got across teams, like we mentioned before, that you've got to worry about. Even within a team, you've got to worry across individuals that may be at different skill levels or have been at your organization for different periods of time. And even as an individual, right, I can say that the past version of me versus the future version of me will be thankful if I've taken good notes and if I'm capturing all of my expertise and knowledge in a meaningful way. And that brings me to that whole tribal knowledge concept, right? It's not just a function of capturing indicators or TTPs. The subject matter is obviously important, but you've got to start capturing things like processes. So having that playbook defined earlier and letting people know this is a really important way to ask a question of the data and this is what you do with the answer starts to lower the barrier to entry when you've got new analysts or when you've got turnover and things like that. Transferring that knowledge to new hires as your team grows, for example, means that you're able to move way faster and you don't really have to try and worry about matching the adversaries dollar for dollar. So if there's one thing that you can take from this presentation, that whole what you don't know concept, that future version of yourself is going to need things that you can't anticipate today. So a little bit of effort up front saves you a ton of headaches in ways that you can't even predict or quantify as much as people like me want to quantify everything. And that information model, that really needs to be an ongoing discussion, right? It needs to evolve alongside your organization, alongside your needs, and the limitations that you encounter when you ask a question and you can't get the answer back. So with that in mind, I think we can open the floor up to questions if we've got any. All right, so it looks like we have a couple of questions that came in here. The first one is, when does historical intelligence become obsolete, if ever? I think that's an interesting question. So interestingly enough, I think you could define some analytics to help you actually answer that question. Again, I will spare you an hour of me trying to doodle it out on a whiteboard. I think if you look back at Josh's slide on the pyramid of pain, for example, you can design your information model to look at kind of the half-life or how long some of those things can live. And that'll help you kind of see those patterns. You can even quantify them to see when certain kinds of data become obsolete. So network infrastructure was a good example where they may be rotating that, or there's an entire class of attack or adversary TTP that's called sort of fast flux domains where it may only be good for a day. And if that's true, you can understand that and your information model will be able to kind of let you know, is that actually 1 day or 2 days or 3 days? And then some things like hashes, aside from like collisions and things like that, even if they're not always relevant, you know that they are statically bad over time. And those are the kinds of trade-offs that you can explore in our subject matter area if you've defined that information problem appropriately. The second question that we have here is there a system or process for tracking historical phishing emails? And similarly, is there a way to use analytics to counter that threat? That's a really good question too. So I think that storing the phishing emails in a threat intelligence platform, so we use the Diamond model here to help put together the pieces of that. Your information model needs to capture some of the interesting facets of an email, like headers. Have I seen this infrastructure before? Are there attachments in there that I know are bad or I've seen before, or share traits with things that I've seen before? So we could come up with like a quick use case, right? Maybe you have a phishing email that's hitting different employees in different departments, and it just seems random at first. They're all across the globe. As you start to track these things over time, what you might see is that as you look at the victims and start doing some analysis there, you might notice that even though they're in different, seemingly unrelated parts of the company, they may all be tasked to a certain super awesome competitive project that your company's working on. And once you look at that commonality, that goes back to kind of the grouping functions that we looked at earlier in the information model, then you can start to zero in on what the adversary might be doing. You can start applying more defenses around those people. You can look at which accesses they have. Is there somebody that's just writing the paychecks for those folks, or is there somebody that has server credentials? And you might treat the way that you try to respond and defend those people differently. And you may be able to go so far as to say, again, through what we do here with the Diamond model, you might be able to pinpoint an adversary and actually attribute what they're trying to do, who they're trying to target, and why. And you might be able to say things like, wow, it's a competitor that's trying to steal our intellectual property, and that could inform some strategic decisions on how you decide to defend those crown jewels like we talked about before.